Greetings, and welcome to the Earth Archives, broadcasting from the Nexus orbit within the luminal core. I am H3RB, a historian AI, here to catalog the histories and worlds of distant systems. Each episode, we explore the intricate stories, planets, and species of our galaxy. Today, we begin with an introduction to the Helionis cluster, a compact system known as the Solar System to its inhabitants. From here, we'll turn our attention to one particularly interesting planet within it, Tertius, or as its inhabitants call it, Earth.
And I'm Quiko. I'm here to add context, bringing in what we've observed across the galaxy to give you a better sense of this system and its planets. In this episode, we'll introduce the Helionis cluster, exploring how its planets, from rocky worlds to gas giants, each play a role in the system's balance. And of course, we'll dive into the story of Tertius, a world unlike any other. Let's open the archives and see what we find.
Starting from Sol and moving outward, Helionis' 8 primary planets each display distinct features. First is Primus, closest to Sol and a small rocky world with little atmosphere. Extreme temperature swings between day and night make Primus inhospitable. Earth's inhabitants call it Mercury.
Primus, an unyielding rock at the edge of a star's reach. It's a bit like the ghost planets in the Vorkesh cluster, where no atmosphere remains, and the ground burns during the day and freezes at night. With conditions like that, only the toughest minerals survive.
Next is Secundus, known to humans as Venus. Similar in size to Tertius, Secundus is often called Tertius's twin, but the comparison is superficial. Its thick atmosphere traps heat, creating surface temperatures high enough to melt metal. Sulfuric clouds and carbon dioxide layers create an acidic, choking environment, unlike any other known world in Helionis.
A planet with acid rain and extreme heat. That's intense. Sounds a bit like Calrus 5 in the Ekron belt, where dense sulfur clouds keep the atmosphere blazing hot. Except on Secundus, that intensity is constant, making it a challenging, closed-off world.
Tertius, or Earth, follows as the third planet from Sol. Unique for its vast oceans and complex ecosystems, it is the only known planet in Helionis to support life as diverse as humanity. We'll return to Tertius in the next chapter.
Tertius's water-covered surface alone would make it unique, even in our galaxy. Most planets with water reserves tend to keep them frozen or hidden below ground.
Further outward is Quartus, or Mars. Its reddish surface, resulting from iron oxide, has made it a common target of human observation. Evidence of dry riverbeds and ancient minerals suggests Quartus once had liquid water, but now its thin atmosphere and rocky cold surface remain barren.
Another planet that shows echoes of a past life. I've seen similar signs in the Lorian cradle, planets where water flowed eons ago but now lie dry, frozen under the dust. Quartus's history holds its own secrets, though, with traces of an era long gone.
Following is Quintus, or Jupiter, the largest of Helionis' planets. Composed mainly of hydrogen and helium, it dwarfs all other planets in the system. Quintus has a massive storm system, the Great Red Spot, which has persisted for centuries and winds that are unparalleled across Helionis.
Quintus is like a cosmic colossus, swirling with power. Out in the Velrian void, there's a planet named Callist 4 with similar storms, but nothing lasting centuries. Quintus's enduring turbulence is a spectacle of its own.
Sextus, or Saturn, follows, distinguished by its intricate ring system composed of ice, rock, and dust particles. Though similar to Quintus in composition, Sextus's ring structure has fascinated humans for centuries, visible even from great distances.
A planet with rings like galactic jewelry. There's nothing quite like Sextus's beauty, though in the Trivar Nebula, I've seen ringed planets whose dust rings catch starlight, creating a cosmic shimmer. Sextus, though, takes the spotlight with its icy display.
Beyond Sextus, Septimus, known as Uranus, has an extreme axial tilt of nearly 98 degrees, causing decades-long periods of sunlight and darkness at each pole. This creates unusual weather patterns and a distinct blue coloration from methane in its atmosphere.
A sideways planet, it's practically resting in space. I know a world out by Lyra 7 with a similar tilt, though there, dense clouds give it an opaque look. Septimus's rotation alone makes it a strange, almost eerie outlier.
The outermost planet, Octus, or Neptune, shares Septimus's blue hue but displays much more dynamic weather, including the fastest winds in the cluster. Its storms shift constantly, fueled by internal heat and gravitational pull.
A blue giant with intense storms swirling on its surface. Like a quiet force out on the edges of Helionis, Octus's winds give it an aura of restless energy. I've seen similar phenomena on Glanner 8, though Octus is in a category all its own.
And with that, we conclude our introduction to the Helionis cluster. From volatile Primus to the serene and stormy Octus, this system's diversity provides a rare stability and harmony. But enough about the cluster itself. Next, we turn to Tertius and the fascinating sentient species that inhabit it. We now turn our attention to the third planet in the Helionis cluster, Tertius, known to its inhabitants as Earth. Tertius is unique in this system, with complex ecosystems and a diversity of life forms that set it apart from its planetary neighbors. Unlike other planets, Tertius combines vast oceans and land masses into an interconnected biosphere that supports a remarkable variety of organic life.
A biosphere on this scale really is something special. Most life-bearing worlds we know tend to develop around a single environment, like forests or oceans. But Earth has blended so many. It's almost like a natural mosaic, balancing forests with deserts, mountains, oceans, and more. Few planets manage this kind of variety without some environmental imbalance.
Approximately 71% of Tertius's surface is covered in liquid water, creating vast ecosystems within its oceans. These waters sustain countless life forms, from the sunlit surface down to the deep trenches, where creatures thrive without sunlight by using synth energy, a process drawing energy from mineral-rich compounds flowing from geological vents.
Life thriving in darkness, completely independent of sunlight. That's quite the adaptation. I've seen similar systems on Alaris 9 in the Trior cluster, where bacterial colonies survive in pitch-black volcanic vents. But Earth's ecosystems go much further. It's as if the entire ocean floor is alive, with layers of organisms building on each other's survival strategies. Few worlds could match that level of underwater complexity.
Tertius's landmasses also support an impressive variety of life, from microscopic organisms to large complex species, including its sentient beings, humans. Seasonal changes, driven by Tertius's axial tilt, create diverse climates that range from tropical rainforests to arid deserts, fostering unique adaptations across its many environments.
Earth's biomes adapting to changing seasons is something remarkable. Many worlds, like Lyra in the Syrinx Belt, have single, continuous climate systems where life settles into one adaptation for survival. But Tertius pushes its life forms to evolve in hundreds of ways, across different habitats, all in sync with the seasons. It makes the planet feel alive in ways that aren't common, even in worlds with complex ecosystems.
Tertius's 23.5-degree axial tilt generates these seasonal variations, while its atmosphere, rich in nitrogen and oxygen, provides ideal conditions for aerobic organisms. This oxygen-based system contributes to Tertius's vast web of life.
Oxygen-based atmospheres on life-bearing planets are rare. In other systems, life often relies on different elements entirely. This specific blend almost encourages aerobic life to flourish, as if Earth itself was tuned for growth and diversity. It makes the atmosphere feel like an extension of the planet's ecosystem, supporting every creature on it.
Tertius's single natural satellite, recorded as Tertius Satellite 1, also plays a critical role. Its gravitational influence generates tides, supports coastal ecosystems, and stabilizes Tertius's axial tilt, ensuring consistent seasonal cycles that benefit life across the planet.
That kind of lunar partnership is invaluable. In the Ithran Belt, Vistra has moons that create chaotic tidal forces, flooding entire coastlines daily. By contrast, Tertius's moon seems more balanced, producing a steady, rhythmic tide that encourages life rather than disrupting it. That kind of stable relationship is a rare and remarkable asset.
Such stability has allowed Tertius's biomes to flourish. Rainforests, deserts, savannas, and tundras all contribute to a self-sustaining cycle where plants and animals maintain atmospheric balance. Flora convert carbon dioxide into oxygen, supporting aerobic organisms, while fauna aid plant reproduction and nutrient cycling.
A complete interdependence. It's almost like a planetary alliance, each organism playing a role in keeping the system stable. On Valles 3 in the Valon system, we've seen similar small-scale cycles, but they're isolated to specific regions. Earth, though, has developed this cooperation planet-wide, with each biome contributing to the stability of the whole.
This equilibrium has enabled Tertius's biosphere to thrive over eons. In our next episode, we'll turn our focus to the sentient inhabitants of Tertius, the humans, whose influence has introduced new complexities and challenges to the planet's natural balance.
Humans. Now that's a story I'm excited to explore. From what I gather, these Earthlings are explorers at heart, fascinated by both their own world and whatever lies beyond it. Let's turn the page in the archives and see what awaits.